In part one of this exam, we're supposed to check if the reported last trade price and yield for Carvana bonds are consistent with each other. So we're going to need a couple of ingredients to do that. We're going to need the maturity date, which is 5/1/2030. We're going to need the settlement date. Now the trade date is February 2nd, 2023. So let's check. That was a Thursday. So 2 business days would be Friday and then Monday. We're going to put settlement date as 2/6/2023. We're going to need the coupon rate, which is 0.1025, 10.25%. Sure, we could make that as a percent. All right, and let's calculate the price given the yield. So we're going to use the price function. The settlement date is here. The maturity date is here. The rate, it's the coupon rate, is here. The yield is 22.554. So we're going to write 0.22554. The redemption is 100. Frequency is semi-annual. And the frequency, we're going to keep 360. We're going to close that. And we see that the price, if we bring it down to 2 decimal places, is exactly $57, just like the quoted price in this screenshot. We can check that the yield is also consistent with the price. We're going to do yield. The settlement date is February 6th. Maturity date is here. The rate is 10. Price is 57. Redemption is 100. Frequency is semi-annual. Days basis is 360. I'm going to hit enter. Oh, we got something is off. Frequency 2, redemption 100. Price is 57. The rate is G5. That's okay. Maturity is G3. It's not G42. It's G4 is the settlement date. Okay, and making that a percentage, adding some decimal places gives us 22%.55. So they are consistent with each other. What is the accrued interest on the bond at the settlement for the last trade date? So we can calculate coupon days from the beginning of the coupon period to the settlement date. Let's do that. Settlement date is this date. Maturity date is this. Frequency is semi-annual. Basis 360. And we have 95 days since the last coupon day. We're going to calculate how many coupons how many days between coupons. And that's number of days in the coupon period that contains the settlement date. So that's going to, again, ask us for the settlement date, the maturity, the frequency, and basis. I'm going to close that. That's 180, 6 months. And now we have to calculate the accrued interest. So one coupon payment here per $100 par would be 100 times the coupon rate. But the accrued interest is only the fraction of the days that have lapsed since the last coupon day, which is 95 out of 180. And well, actually, the coupon, since the coupon is annual coupon, we only get half of that, so we have to divide that by half, and we see that the accrued interest is $2.70. All right. What is the dirty price of the Carvana bond? Well, it's the clean price plus the accrued interest, which is $59.70. Suppose you view these bonds as riskier than the market. How would that affect the price you're willing to pay for the bond? How would it affect the yield? Give example and discuss. So if I view this bond as riskier than the market overall, I'm going to require a higher yield to compensate me for that additional risk that I perceive. And so I would pay less. I can show that if I calculate price at the settlement date, given this maturity date, given this coupon yield, and let's say I require 25% instead of just 22% yield. The redemption is 100, annual 0, and I'm going to pay only $51 or $52, round numbers speaking, instead of $57. So clearly, if I view the bond as riskier, yield goes up, price goes down. So in this question, suppose that you know that Carvana will call this bond at the next call date at the par value. How much would you pay for the bond and maintain the same yield to maturity? Make the calculation and carefully explain the intuition. So if they call the bond back and make the redemption at par value, it's as if we changed the maturity from the original maturity of 5/1/2030 to the maturity of 5/1/2027. So they're going to pay back the bond full 3 years earlier. So let's put in new maturity date. And that's going to be 5/1/2027. Now let's calculate what the price should be. So price settlement is still the same. Maturity now is different. Rate, that's coupon rate, it's the same. Yield is going to be the same as before, 22.55. Frequency is semi-annual. Oh, I forgot the redemption. Redemption is 100, and the basis is going to be 0. We're going to leave it, and the price goes up. So I'm going to actually pay more for this bond. And what is the intuition? So on the one hand, if they recall the bond 3 years earlier, I'm going to miss out on a bunch of coupon payments. Right? There's going to be fewer coupon payments, so I should pay less for the bond. However, I'm going to get the face value earlier. And since the discount rate that I'm applying to this bond is so high, the effect of the higher discount rate is going to outweigh the effect of fewer coupon payments. So I'm happy to forego the coupon payments because I discount them at a really high rate. And I really value the fact that the money is going to come 3 years sooner. So I'm going to be willing to pay more for the stock, for the bond. Excellent. Let's go to part 2. In part 2, we have some information on Pepsi and Coke stock prices. And we have to find geometric average, arithmetic average, annual, monthly, calculate risk and return on portfolios. All right, so what are we going to need? We're definitely going to need returns, monthly returns on these 2 stocks. So this, we've got adjusted close, so that's going to be pretty easy for us to calculate. total returns every month. It's going to be adjusted closing price today minus adjusted closing price yesterday, divided by the adjusted closing price yesterday, or rather previous month, since this is monthly data. That's giving us 0.87%. Let's copy, Control D that all the way down. And actually, we can Control C and Control V. Oops, Control V. No, all right, let's do it again. Control C, Control V. We're going to calculate this. That's the formula that we want. N5 minus N4 over N4. And we're going to copy that down so that we have it for all of the months. Control D. Let's calculate the average return. So let's do average return. And I think it looks like we're also going to need standard deviation because we're going to be calculating some portfolio risk and return. So let's do average of this whole series. So end arrow up. That's this. I'm going to do standard deviation. I'm going to use the S formula. And again, it's going to be this series. Enter, and we can copy that for Coke. So we have it done for all of them. Control V. All right, so Pepsi had about 1.4 monthly returns with 4.94 standard deviation. Coke did much better with a lot more volatility. All right, so arithmetic average returns. So we already did that. I'm just going to link the cell. So we have that. What is the geometric average return on Pepsi? Well, we can use our beginning and end values. So we know that the ending value is would be this one, the adjusted close. I divide that by the beginning value. If I started basically with $111 at the end of February 2020, by the end of February 2023, I would have $176. And if I raise that to 1 over, I have 36 periods. I have 3 years worth of data. Minus 1, that's going to give me the geometric average return. Right? Not that different from the arithmetic average. Getting a geometric average annual return, well, I can do the same thing. I can see that I ended with $176 and started with $111, and now I need to raise it to teeth root. What is a T in this case? In this case, it's 3 years. So I'm going to divide that, raise it to 1 over 3 minus 1 gives me 16.5%. So monthly average 1.2 goes down to about 16.53 annual. Because I can calculate that another way. I could just take really 1 plus the monthly return and raise it to 12th power. Okay, and subtract 1 from that, and it will give me the same number. Calculate monthly risk and return of portfolios in 10% increments. Let's do that. So this is going to require some setup. So we're going to need, well, we're going to need actually covariance between those two returns. So let's calculate that. Covariance is going to use the S formula between this range and this range. Parentheses closed. That's the covariance. Yeah, we got the ranges correctly. We're going to need to set up different portfolios. So I'm going to do weight of Pepsi. I'm going to start with about, we started here, sure, one, oops, no. Let's do it here. One is the first weight. We're 100% in Pepsi, and let's change that by 0.1 by 10 percentage points. Let's stretch this maybe to here. Control R. Yeah, I guess I just gonna hard code this to 0. Okay. So average return, that's pretty straightforward. The average return is going to be the weight of Pepsi times the return on Pepsi, and we're gonna log that plus 1 minus the weight on Pepsi times the return on Coke, which is here. And we're gonna have to lock that. So F4. And of course here it gives us 1.4, which is because we're 100% in Pepsi. And if we're 100% in Coke, then we have 3.48. Standard deviation, that's going to be square root of, and this is a big long expression, so let's be careful about that. We're going to take the weight of Pepsi squared times the standard deviation on Pepsi locked and squared plus 1 minus the weight on Pepsi squared times the standard deviation on Coke locked squared, because we need variance there, plus 2 times the weight on Pepsi times 1 minus the weight on Pepsi, which is the weight on Coke, times the covariance, times the covariance between those two, which is right here. And we're going to lock that one. Something's off. I believe that we forgot to close the parentheses. Yes, and Excel fixed that for us. That's excellent. We can control write that all the way, and that actually looks pretty good. That actually looks pretty good, because we end up with the standard deviation of 100% Coke is equal to the standard deviation of Coke. What is the minimum variance portfolio? So let's calculate minimum of, let's do it as a function, minimum of that range. It looks like it's going to be 100% Pepsi. 100% Pepsi is the minimum variance portfolio. Assuming that the risk-free rate is 2% per month, what is the tangency portfolio of Pepsi and Coke? So in this case, we need to do something similar to what we did here. We need to construct a portfolio of, actually, no, we have to calculate, Sharpe ratio. Okay, so we'll do Sharpe ratio and Sharpe ratio. So, but for Sharpe ratio, we'll need the risk-free rate. So, you know what, let's type here, risk-free is going to be 0.2. Oh, it's formatted as percent, so I'm going to do just 2%. No, 0.2%. And I'll do Sharpe ratio, and that's going to be the average return minus the risk-free rate locked divided by the risk, by the standard deviation. And I can control write this. And I can find what is the maximum Sharpe ratio, max of this range is 0.308, and that corresponds to 0.7 weight on Pepsi, 0.3 weight on Coke. So that's our tangency portfolio. Oops. I don't know why it disappeared. All right. So fantastic. We know the tangency portfolio. Suppose now we have the option to also invest in a risk-free asset. So we know how to do this. So we're going to now have to create a portfolio that consists of the risk-free assets and the tangency portfolio. So I'm going to copy these weights down here, but it's going to be really the weight. Oh, I guess I'll do it down here. Weight of the, well, let's do it this way. Weight of a risk-free asset, and I'm going to do Control V. No, I'll take this. Control C. Control V. I'm actually going to extend this so that we can possibly go into negative as well. Right. And hard code, this is a really low number. I'm going to make it true 0. And so now I need to know what is the average return. Well, the average return equals, it's going to be the weighted average of the risk-free return and the return on the tangency portfolio, where the weights are these numbers up here. So it's going to be weight on the risk-free times the risk-free rate plus 1 minus the weight on risk-free times the return on the tangency, which is 2.02. And we have to lock that one. And we actually have to lock the cells that mark the risk-free rate as well. Yeah. Get 0%. Why are we getting 0%? We should get 0.02. I think I see the problem. I put in times instead of plus. So this has to be plus. And I'll hit enter on that. And I'm gonna control write that. That makes sense. If I'm 100% in the tangency portfolio, I'm earning 2.02. Let's calculate the standard deviation of a portfolio that mixes the risk-free asset times the tangency portfolio. And that is a formula that only involves the variance of the risk of the tangency portfolio. And it equals the weight on the tangency portfolio, which is 1 minus the weight on the risk-free asset. Well, I should square it and then take the whole thing over square root. But if I take the square root, I can actually get rid of the square. And instead of using variance, I can just use a standard deviation. So this is going to be a simpler formula. If I just now make this the standard deviation of the tangency portfolio, it's going to give us 0 because there's no risk if I'm 100% in a risk-free asset. Controlling right that something is not right because I probably forgot to lock certain things. I forgot to lock the standard deviation of the tangency portfolio. So I'll do that with F4, hit enter, and copy that to the right. And what do I get if I'm 100% in the tangency portfolio? I get the same risk. If I go short risk-free asset, the risk increases. Fantastic. If I want to invest my money while keeping my risk below 4%, what do I need? I need to actually invest 0.4 in the risk-free asset. So the weight on risk-free is 0.4. The weight on Pepsi and weight on Coke, it has to be 70-30. So I need to divide 0.6 into not equal shares, but really 30% of that 0.6 needs to be Coke, and 0.7 of that 0.6 needs to be Pepsi. So that will be 0.7 times 0.6. That's 0.42. And on Coke, the weight on Coke has to be 0.3. So Coke gets a 30% of that 0.6. That gives us 18. What does it add up to? It adds up to 1. Fantastic. So the last question asks, how would the results change if instead of creating a portfolio of Pepsi and Coke, you were creating portfolios of Pepsi and Microsoft? Would the minimum variance portfolio have less risk? Would we have a higher Sharpe ratio? No calculations needed, just intuition. So I suspect that the correlation between returns on Microsoft and Pepsi is lower than the correlation between the returns on Pepsi and Coke, since Microsoft and Pepsi are in a very different business, whereas Pepsi and Coke are in the same business. When we have a lower correlation between the returns, we have more opportunity for risk diversification. Whether the minimum variance portfolio would actually be lower if we mix Microsoft and Pepsi rather than Pepsi and Coke really depends on the risk of Microsoft, because the portfolio variance depends on the variances of the two individual securities and their covariances. If the decrease in covariance is sufficiently large, and even if Microsoft has slightly higher variance, the minimum variance portfolio could have a lower risk, but it's by no means guaranteed. So then whether we could achieve a higher Sharpe ratio, well, that depends not just on the variances and covariances, that also depends on the average return of Microsoft. For example, if average return on Microsoft is really, really low relative to that of Coke, then mixing Pepsi with Microsoft is not going to get us a higher Sharpe ratio.